If we take a look at this ether and notice we have an R group on either side of our oxygen like that. And if we wanted to name ethers, there are a couple different ways to do it. We'll start off with the common way of naming ethers, which follows the pattern of first naming one of the alkyl groups attached to your oxygen, and then naming the other alkyl group, and then followed by the word ether, like that. So alkyl, alkyl, ether. Let's look at an example of common nomenclature, and we'll start with this molecule here. So if I wanted to name this ether, I would first focus in on what sort of alkyl groups do we have attached to our oxygen. Over here on the left, that's a methyl group, and over here on the right, that's an ethyl group. So we need to think about the alphabet rule, and we know that E comes before M, so we're going to write ethyl before methyl, so it will be called ethyl, methyl, ether, like that. So let's do another one. Alright, so our goal is to name this ether, and we first, of course, take a look at the alkyl groups that we have attached to our oxygen. So on the left here, we recognize this as being a tert-butyl group, and on the right, we have a methyl group. So in thinking about using the alphabet rule, right, B comes before M, so the tert-butyl group is going to come before the methyl group in the name, so it should be called tert-butyl methyl ether, like that. So the tert part isn't a part of the alphabet, right? You're comparing the butyl versus the methyl, like that. Now, tert-butyl methyl ether might be the correct name, although that's probably not what you will hear this molecule called in the laboratory. Usually, you'll hear this called methyl tert-butyl ether or MTBE. So MTBE is a very common organic solvent. It works very well for a number of things. And again, MTBE is what you will hear, but technically that's not the correct name. Let's look at an ether that has alkyl groups that are the same. So if we have this as our ether, we have two ethyl groups for this one. So we're going to call this diethyl ether. So diethyl ethers, or you can use the prefix of di here. Now, diethyl ether, of course, is the famous one. This is the one that everyone thinks of when they think about ethers. Let's look at another way to name ethers, and this is the official IUPAC way of naming them. Now, the common way of naming ethers is so common that it's accepted by IUPAC nomenclature. But there is an IUPAC way of doing it for more complicated molecules, and that is to name your ether as a substituent, which we call an alkoxy. So we're going to name ethers as a substituent, and then have a parent alkane. So we're going to call these alkoxy alkanes, like that. All right, so what you would do is if you had just this generic ether here like this, RO R you would find the larger alkyl group, and that would be your parent name. So let's say the R prime group was my longer carbon chain. That would be my parent alkane name, like that. And then you would name this portion of the molecule, right, as an alkoxy substituent on your alkane. So let's look at an example of IUPAC nomenclature. So let's go ahead and we'll name that first one, that first ether that we did a few minutes ago, right? So the very first one we did when we were doing common nomenclature, right? We called this ethyl methyl ether. All right, so let's go ahead and name it using IUPAC nomenclature here. So what we would do is find the larger group, and that's going to be my parent name. So my larger group would be this over here on the right. And if we were to number that, right, you could say that's number 1 and number 2 right here, number 1 and number 2 if you wanted to. You don't really have to for this example, but just to get you thinking about longest carbon chain, right? That would be ethane right there. So we'll go ahead and write ethane as our parent alkane name. And then what do we have coming off of the ethane portion of the molecule here? So what is our substituent? Well, this is the ether portion. We're going to name it as an alkoxy. And since we have one carbon to deal with, right, we know that our root is meth. And as an alkoxy, it'd be methoxy. So the complete IUPAC name for this molecule would be methoxy ethane, like that. And we don't have to worry about numbers since we have only 2 carbons on our parent chain here. So methoxyethane would be the IUPAC name for this molecule. The common name would be ethyl methyl ether. Both are acceptable names. Let's do another one where we have a very similar looking molecule, except in this case we're going to add on another carbon there. So if I'm thinking about my parent alkane over here on the right, there would be 3 carbons for my parent alkane. So if I wanted to number that, it'd be 1, 2, and 3. A 3-carbon alkane is, of course, propane. So I go ahead and write propane right here. And I look at my ether substituent once again, and I look and see how many carbons I have. And there's one carbon on the substituent. So once again, it would be methoxy. So I'll go ahead and write methoxy in here. So methoxypropane. Okay, this time I need to put a number on there, and that group is coming off of carbon 2. So the complete IUPAC name would be 2-methoxypropane, like that. Let's do a much more complicated one that has a little bit of stereochemistry in it. So if this was the molecule that I was trying to name, and let's go ahead and put a bromine here like that. All right, so for this one, once again, I have to think about the larger group as my parent name. So if I look at those 2 alkyl groups, the alkyl group on the left looks like the longest one to me. And I want to number to give my substituents the lowest number possible. So if I look over here on the left, I can see that there are 4 carbons in my larger substituent. So 4 carbons is going to be my parent name here. So I'm going to call this butane. So let's go ahead and start naming it with butane right here. So this would be butane so far. Now when I number that butane, I want to give the lowest numbers possible to my substituents. So I could start from the left or I could start from the right. And starting from the right makes more sense because I have a substituent coming off of carbon 1, I have a substituent coming off of carbon 2, and then 3 and 4, like that. All right, so if I'm thinking about those 2 substituents, right, let's think about how I would name them. All right, so over here on the right, for my alkoxy substituent, this time there are 2 carbons in my alkoxy substituent, right here. So 2 carbons would be eth, so that would be ethoxy. And ethoxy is coming off of carbon 1. So I can go ahead and write that in here. So 1-ethoxybutane is what I have so far. And I also have a bromine coming off of carbon 2. So it would be 2-bromo. So I can go ahead and put in 2-bromo. 1-ethoxy, and that follows the alphabet, right, because B comes before E. So 2-bromo 1-ethoxybutane, and then we have to worry about the absolute configuration at this carbon right here. So carbon 2 is a chirality center, so we need to think about how to assign priority to those 4 groups. So if I think about the atoms directly attached to my chirality center, first let's go ahead and identify my chirality center. That would be this one right here, right? 4 different groups attached to it because there's also a hydrogen going away from me in space. And I think about atomic numbers, right? So I have carbon versus bromine right here. So bromine, of course, has the highest atomic number, gets highest priority like that. Now, my hydrogen, of course, is going to get lowest priority, so that's priority number 4. And now I have 2 groups to worry about, right? So I have 2 carbons to worry about. Let's go ahead and mark those carbons again. So which one of these carbons is going to get higher priority? Well, it's all about what they're attached to, right? So the carbon on the left is attached to another carbon and 2 hydrogens. The carbon on the right is attached to an oxygen and 2 hydrogens. So in terms of atomic number, right, carbon versus oxygen, the oxygen will win, and this substituent on the right would get the highest priority. So this would get a 2 over here. All this stuff over the right would get a 2, and over here on the left this would be a 3. So we have 1, 2, 3 going around this way, going around counterclockwise, which is the S absolute configuration. So this is S2-bromo 1-ethoxybutane for the final name. Let's do one more example of naming an ether here. So let's go ahead and look at one that has a ring, and we'll put a double bond in our ring like that, and then we'll have our ether over here on the right. Okay, so if I wanted to name this molecule, I would think about my 2 alkyl groups and think about which one is the larger one, and of course all this stuff on the left, right, is going to be my parent name, and then this is going to be my alkoxy substituent, like that. So on the left, I know what that molecule is. I know that's called cyclohexene from an earlier video, right? So this is cyclohexene as my parent name. So cyclohexene. I now need to number my ring to give my alkoxy substituent the lowest number possible. Right? So if I wanted to number my ring to give my alkoxy substituent the lowest number possible, I should start here and make that 1, 2, 3, and 4, like that. So we think about what is that alkoxy substituent. It is an ethoxy group, right? Because an ethoxy substituent, because I have 2 carbons right there. So I have an ethoxy coming off of carbon 4, so this would be 4 ethoxy. And if you wanted to, you could put the 1 in here, 1 cyclohexene. You could leave it out if you wanted to, so it doesn't really matter. But 4-ethoxy, 1 cyclohexene gives you all the information that you need if you wanted to draw this molecule. So that does it for nomenclature of ethers.